Hey guys, welcome to the channel, and in this video I will be explaining you one question on tree, that is to find the branch sum for a given tree. So we have to find the sum of all the branches in a given tree. So now let's see with the example what I mean by branch sum. Suppose if we have given this tree where the node represent the value and edges represent the link between the left child and the right child, and the node structure we have given. So in the node structure we have the value, we have the left child, we have the right child, and we have used the constructor to initialize the value which we have passed from the main functions. Suppose if we want to create this node number 1, then we will simply make one object of node and initialize with the value which we want to give it to it, and initialize the left and the right pointer to null. So suppose this is the node structure which we have given to us, and this is the tree which we have given to us. Now our task is to find the branch sum. So branch sum means these this represent one branch. Suppose if we take one branch as 1, 2, 4, 8, this represent one branch. 1, 2, 4, 9, this also represent one branch. 1, 2, 5, 10, this also represent one branch. 1, 3, 6 also represent one branch, and 1, 3, 7 also represent one branch. So in this problem we have given 5 branches and we have to find sum of all these branches. So now let's see how to solve this. So from the main function what we are doing to do is we are calling the branch sum function. In that we have passed this root node. So I will write the values of the node which I have called. So I have called the node 1 with the initial sum of 0, because currently we don't have any sum, we have 0 sum, and we will calculate the sum as we move further. So when this function is called with the root node as 1, then the first step it does is the whatever sum it receives, it adds the current node value to it. So we have now sum of 1, and this sum is passed to the left and right child of this current node. So in the left child we have passed the left pointer, that is second node, this second node, with the sum as 1, and in the right child we have called branch sum of 3 and 1. When the left child is called, the sum is calculated. Now the initial sum which we got from the ancestor is 1, and we have the current sum of 2 in this node. So now the sum is 3 for this particular node, up to this particular node. Now it will call its child, left and right child, with the branch sum of 3. So node number 4 is called with branch sum of 3, and node number 5 is also called with branch sum of 3. Likewise, the right child calculate the corresponding sum. So it has the sum of 4, and it will call the left child branch left child 6 with a sum of 4, and it will call the right child 7 with a sum of 4. After that, when we are at here 4, 3, so it will call left and right child with a branch sum of 3 plus 4, that is 7. So it will call a branch sum of 7. Okay, sorry, not 4, this is 8, this is the 8th node. After that it will also call the right child 9 with a branch sum of 7. Okay, and this node 5 also has one right child, so it will call branch sum of right child, that is 10, with the sum of 3 plus 5, that is 8. Okay, so once you encounter the leaf node, like in this case we have a leaf node 8, leaf node 9, leaf node 10, leaf node 6, and leaf node 7. So in this case what we need to do, we need to sum first this branch sum and the current value, that is 7 plus 8, which we got is as 15. We got the branch sum here as 7 plus 9, that is 16. We got branch sum here as 8 plus 10, that is 18. We got branch sum here as 4 plus 6, that is 10, and we got branch sum here as 4 plus 7, that is 11. Okay, so these are the branch sums at the leaf node, and when it calculates it, we store just for we can directly print this branch sum also, or we can store in some vector so that we have all the branch sums with us. So this branch node, this leaf node shows that there is a path from the root node to this leaf which has a sum of value 15 or either 16 or 18 or 10 or 11. So we got the branch sum of the individual branches. As I showed you also that there are 5 branches in this question, in this example. So that 5 branches has the sum of 15, 16, 18, 10 and 11. So this is the answer which we got. Okay, so first thing, the thing you need to notice here is I have used the preorder traversal for calculating the branch sum. That means I will just first manipulate or use the value, after that I will call the left child, and after that I will call the right child. So you can use this preorder traversal to find the branch sum. Now as you know that preorder traversal takes O of n time complexity for traversing all the nodes if we have n node, and in worst case it can go up to O of n space complexity if we have a tree like this, that is only in the one direction. Okay, so if we have a tree like this, then all these values or all this function call will be pushed onto the stack, and stack can go up to size of O of n. So the time complexity in this case is O of n, and the space complexity in this case is also O of n. Now let's see how to code this. Here what we have, as I have showed you in the example, that I have created a tree with childs with the nodes as 1, 2, 3, 4 and so on, and I have also showed you that I have used this structure to create the node in which I have value, the left pointer, the right pointer, and I have initialized this with the help of the constructor. So this is the basic initialization. After that, from the main function, I have called this branch sum function with initial sum of 0 and the root node, and the answer is a vector which I took, which will which contains our branch sums for all the branches. Okay, so you can either directly print the branch sums. So in this case I have used the vector which stores all the branch sums, so that at the end we have all the branch sum in the vector. Now we have this branch sum function which is called from the main function, in which we have passed the root node. The sum initially I have passed as 0, and the answer is a vector which keep tracks of the branch sums, or it holds the branch sum for all the branches. Now if we at any point of time reaches the null node, that means after the leaf node, that means null node, then we simply return from here. We does not have anything to explore after it. If this is not the case, then the sum which we got from our ancestor, we have to add that sum with the current node value. So this is the sum up to that point, and this is the condition checking for the leaf node. So if any point of time, if we reach this leaf node, then in this case what we need to do, we need to simply put our answer in this answer vector which I have took, because we found out our branch sum for that particular branch, and we return from there, because from leaf node we does not have any left child or right child to explore. Now once this is not a leaf node, that means that is any internal node. This can be this, any internal node. In this case what we need to do, we need to call the left child, or after calling the left child with the sum as the sum which we got from here, and we call the right child accordingly. Okay, so if there is no left child, then it will simply return from here, because this condition checks the null pointer or not. So this is basically a preorder traversal, you can say that. Okay, therefore we found out the branch sums for all the branches in this answer vector. So for analyzing the time and space complexity, I have showed you in the example also, the time and space complexity in this case is O of n. Okay, so this is the basic initialization. Now as you know that preorder traversal takes O of n time complexity for traversing all the nodes if we have n node, and Okay, so hope you got this problem of branch sums in a tree. So if you find any difficulty, I will solve that for you. Just drop down the comment for it. Okay, thank you.